All right, welcome. Let's have a look at this question. We are having a question under instruction. A hollow sphere of internal and external radii, that is radius, which are 6 centimeters and 8 centimeters respectively. So it is being melted and recast into a small cones, not one, small cones. A lot of cones are being made from that. Of base radius 2 centimeters and a height of what? 8 centimeters. We have to find the number of cones that were made with the melted material. So the first thing first, we need to know what is the volume of material used in making the sphere. Okay, now it is not a complete sphere. I will not say complete. It's not a solid sphere whereby there is no space. Here there is a space, so we can take it just like a football. If you open the football, the material, there is a thickness of that material. So from the inner part of the material to the center of the ball is the internal diameter or the internal radius. Then from the outer material, how thick that material is from outer to the inside is our external radius. Let's make a sketch of that if we can. We know a sphere is more or less in the form of a circle. That is what we can see. So if there's a thickness, this thickness is showing the material used. So let's say it was a candle or metal. So this thickness, we need to know the material used in making it. The hollow, meaning there is nothing here, no material is here. So a hollow sphere of internal. So if this is the center, don't forget we can have this as what we have. Then we can also take it from, let me take it from here. And below this one a circle, right? The center to this place. So this is our internal radius of 6 centimeter. From here to here, our external of what? 8 centimeters, right? Now, to know the material used in doing this, we need to take away the empty space away. So with all this in mind, we are only referring to volumes. So we can say volume of a sphere by recall is 4 on 3 pi r to the power what? 3. So in this case, we are having a radius here. So we can say that where our capital radius is for the external, 8 centimeter, small r is for the internal, 6 centimeter. So in all, for me to be able to know the volume of material used in making that sphere, I need to take away the internal volume from the external volume to get the volume of material alone. So in this case, I have, so the volume of material used in making the sphere become 4 on 3 pi r, this one will be capital, cube, minus 4 on 3 pi r what? Cube. They are all r, which are representing the 6 and 8 centimeters. If I check from here, 4 on 3 pi, 4 on 3 pi seems to be common factor. So this can be 4 on 3 pi into bracket r cube, then small r what? Cube. So we can substitute our values into that and see what that will give us. So 4 on 3 pi, then I have 8 to the power 3 minus what? 6 to the power 3. I want to manage the space, so let's still write this as, we need to avoid double equal sign on one line as I'm doing, equals to, but I'm managing space. You will not be managing space, so you will write them down vertically. Let's still have our pi in there, then 8 to the power 3, let's check that on our calculator. That will be giving us 512, then 6 to the power 3 will be 216, and fast forward, 4 on 3 pi. If you perform that subtraction, we should be having 296. Don't forget, the top can multiply. Let's check whether that is divisible by 3 first. It's not divisible. So 4 times 296, that should be giving us 1184 pi divided by 3. Remember volume, so centimeter what? Cube. This is the volume of material used in making the sphere. Then we are using the whole of this material to make small cones. Remember, a cone is in this shape. Since it's going to be small, let's just have here radius of 2 centimeter, a height of what? 8 centimeter. There are a lot of these that have been made. So we need to know, if I make this as a clay, if I fetch part of the volume which is this, I am making this. If I fetch, I am making. I will keep on fetching until this volume is finished. Meaning I keep on dividing this by the volume of this that I will fetch. So I need to know the volume of this cone, or just one of the cone. And how do you find volume? Remember, volume of cone is actually 1/3 of the volume of a cylinder, which is 1 on 3 pi r squared h, where the r is the 2 and the h is the 6. By substitution, 1 on 3 pi, what do we have? R is going to be 2 to the power 2 multiplying what? 8. I think that will be 4 here times this 32. So we have 32 pi divided by what? 3. All right. What is next? Now that we know the number, the volume of 1, then it means that I am dividing this in terms of volume by volume. This is also going to be centimeter cube. So I'm dividing this by what? This. Or in the actual sense, the volume of what do you call it? The volume of material used in making the sphere is equals to the volumes of all the cones that I will be making. If I can put it this way, so I can say volume of sphere will be equals to the number of cones I am making. If I make 2 of this, it means 2 times this one. If I'm making 3, 3 times that. So let's use n to represent the number I am making, multiplying the volume of what? Cones. This is what I want to say. And if that is the case, I am looking for this number of the cone. So I divide by the volume of the cone. So dividing the volume of the sphere we had by that of the cone give us the number of cones that were made. So we can say that number of cones made will be equals to the volume of sphere divided by volume of cone. So that means 1184 pi divided by 3, or divided by 32 pi divided by what? 3. Let's fast forward this to be 1184 pi divided by 3. We know this become multiplication. We flip this one to become 3 on 32 pi. This will cancel this, pi will cancel pi. So we are left with 118 divided by 32. And that is giving us exactly 37. So therefore, 37 cones were made. I don't know if you get the concept clearly. We are taking the volume of sphere, restructuring it by melting it to produce a different material or a different shape, which is in this case a cone. So if I know the volume of material, let's just put our mind into clay. That I am having a clay, then I mold the clay to form a sphere. Then I scatter it again without losing any material. Then I take the clay again and restructure small cones. So how many cones I can make will determine by the volume of one of the cone I am making, if they are all the same. So if I make a cone, let's say 3 centimeter cube. So I'll be dividing the volumes of the clay by 3 centimeter cube. That is the analogy we have here to get the answer. I guess this is clear. Feel free to hit me in the comment section with your suggestions and your contribution. Let's keep on learning together. Like, share, comment, and subscribe.